Okay, so we had a little snafu with our recording device here, thus that's why all of the work for this problem is already on the screen. So I'm just going to kind of walk through what I already have written here. We're going to do the problem. It's page 68, number 81. We started with the square root of 3 plus the square root of 8 squared. So what that means is we're going to do the square root of 3 plus the square root of 8 times the square root of 3 plus the square root of 8. Okay. Now, when you're doing these kinds of problems, which is pretty much from 78 to 84, you just have to keep in mind that some of you may remember using FOIL for these. You just have to multiply every term in the first set of parentheses by every term in the second set of parentheses. So I'm going to multiply this one by everything, and then I'm going to multiply this one by everything. Okay? Alright, so when I do that, I've got the square root of 3 times the square root of 3, so that's this term right here, square root of 3 times square root of 3. Square root of 3 times the square root of 8, this term right here. And then I've multiplied this term by everything in the second set, so I'm going to move to my square root of 8 here. So I've got the square root of 8 times the square root of 3, this term right here. And then the square root of 8 times the square root of 8. Okay, now that I've done that, I can do, since I've got two radicals multiplied together here, I can combine them together under one radical since the radicals match. So I've got the square root of 3 times 3 plus the square root of 3 times 8 plus the square root of 8 times 3 plus the square root of 8 times 8. So now if I start simplifying down, I've got the square root of 9 plus the square root of 24, again 3 times 8, plus the square root of 24, 8 times 3, and then plus the square root of 64, 8 times 8. Why that's not wanting to stay. There we go. Okay. All right, so the square root of 9 simplifies down to just 3, because 3 times 3 is 9. We want to break apart this 24 into a perfect square times another number so we can simplify it down as much as possible. And the largest perfect square that goes evenly into 24 is 4. So I'm going to do the square root of 4 times 6. And again, same thing here. And then the square root of 64 simplifies down to just 8. And I do want to make sure that I flag and remind everyone that once you have taken the square root of something and it reduces down to a whole number, the square root goes away. This is not the same. If you write the square root of 3 here, you are going to mess yourself up. Once you have taken the square root, the root goes away. Okay, so now we're down on this line here. I'm going to go ahead and combine my 3 and my 8 and bring that together to 11. Okay. And then I'm going to break apart my radicals here into pieces, doing the square root of 4 times the square root of 6. Again, the same thing here. So, now I've got 11 plus, and this was, again, trying to illustrate that once you've taken the square root of 4, you're just left with 2. That's supposed to be a 2, like this 2. So we've got 11 plus 2 root 6 plus 2 root 6. So, from here, we just have to finish combining our terms, our like terms together. Now the 11, because it doesn't have a root 6 attached to it, is not a like term. Again, so this would be like 11 plus 2x plus 2x. So 11 plus 2x plus 2x would be 11 plus 4x, or 11 plus 4 square root of 6.